Right, hello. This is a C2 video. Now, this is going to get a bit intense. Well, not really, but it's just quite a different tutorial to the ones we've done in the past. This is because this is a trigonometry video. This particular video is on, probably should write it up actually. It's on quadrant rule and how we use the quadrant rule to solve equations of to solve equations and solving the equations. And what we're going to be doing in future videos is changing the identity. But for now, what we're going to do is just basic sort of thing. Okay, so what I'm going to do is sketch the graphs, help you understand what we mean by the quadrant rule, and then use that information to tell us how to use that and why we use that. What I'm going to draw at the top right of, top right, down, bottom, what I'm going to draw at the top right of this whiteboard is the actual quadrant rule itself. Now, don't be concerned that you don't know why we've got this. This is what I'm going to explain. And the purpose of drawing this at the top of the whiteboard now is to allow you to see why this rule is, well, draw it now and then you can see, try and work out how we get it and sort of visualise the answer so you can sort of imagine my next step and see, and I'll explain why each step occurs. I mean, if you want to, you can just ignore it, but I'm just going to draw it up here at the top. I'm not sure if you're going to be able to quite see this, but doing it in a pen that works, so you should be able to. So 0 minus 360. Now again, you might not know what I'm doing, but it'll soon become clear. So 90, 180, 270, plus or minus, all sine. Sorry, I'm just thinking of what goes where, because I've only just done this. Tan x. I'm only just going over this myself, so and I will explain how you remember it, what best ways there actually are to remember this formula. So that's minus 90. And what all these minus 180, minus 90, what they all mean. So that is the quadrant rule there. It's called the quadrant rule because there's 4 quadrants. Now that is like year 7 stuff, but if we zoom in, it looks a bit more advanced than year 7 stuff, and trust me, that's sort of only the beginning of this topic. So it's like, that's actually an A there, all, top left, top right, top left is sine, tan, x, cos, and obviously they're the angles there. So again, you may not have any clue whatsoever or what any of them values mean, but hopefully after these, I mean, you know your basic sine rule, cos rule from your year 7 trigonometry, really. Nothing more advanced in what the sine and stuff mean than that, but for what we use it for. Now, I'm going to just draw the sine, cosine and tan graphs. The tan graphs is a little bit more different. Now, to make sure I get these graphs right, I'm just going to use a bit of a guide in terms of the how to draw it. Now, a way of drawing this, you could simply type in the values of sine of minus 316 to your calculator and plot a point and then join it up. But I'm just looking at this sheet now just so I don't waste too much time. So, I mean, this rule saves you doing this. and you'll see why when I do it. And now this is called a quadrant rule because there's 4 quadrants here. So that's how these two sync up. And now there's 90, 180, as you see the angles going round, 270 and 360. And then on the other side we've got minus 90, minus 180, minus 270 and minus 360. Now this is for every graph. Yeah, what I'm drawing here on this one, this is the sine of x graph. The sine of x graph, you do sine of minus 360, this is minus 1 and plus 1 at the top. And let me just, I'm going to put this in my calculator if I can find it. There it is. Right. I'm going to try and put this in front of the calculator, the camera, whatever this is, this magical device. I don't know if it'll work on this screen. So as you can see at the top left there, we've got the sine graph, and we've got these values going up in 90s and going down in 90s. So let's start with minus. So put it in on position. If you've got this Casio, one of these ones, you pressed. God, sorry, I'm just trying to go through this as easy as you can. So you shift. Oh wait, no, you don't shift. Oh, it's just sign, just the sign button there. It should say sign on your calculator. You type minus 360. It's quite hard to see if it can see on the camera at the same time, and you should get an answer of 0. So obviously it says that is going to be 0. And then if we type in minus 180, if we got minus 270, we should get plus 1, I think. Yeah, so that's got plus 1. So that tells us it goes up from minus 360. And if we do add another 90 on to get to minus 180, we should get 0, which we do. So you can see the shape of the graph already starting to form there a little bit. So if we replicated them actions for the rest of this graph, we'd get something that looks like this. Oh crap, sorry. This is meant to go up to minus 1, by the way. I have to redraw this, sorry. So it goes up to minus 1, goes down. I should have drawn these minus 1s a bit better. Sorry. It's just I've lost my bearings here at all. Minus 180 goes through, yeah, 0. That should go through minus 180 actually. This is a problem in drawing the graph. You can make quite a hash of it, as I'm doing now. So the sign will look something like that. Does it? Yep. I mean, it's a bit scrunched up here. You could do this graph a lot neater than I've done, as you could probably tell. But now what we're going to draw is the tan graph. Sorry, the cos graph even. So this cos of x. This is already starting to look a bit more advanced, isn't it? Hopefully it is. 90, 180, 270. And now what these 270 things, they're just degrees. They are all in degrees. And obviously all I'm drawing is the same axis, and I'm going to replicate this graph except in the context of cos. So we put our cos values in. Now we do exactly the same. We put in our cos, the cos of each one of these values, and a minus 360 is 1. And it goes down to 270, and we have sort of a pattern going again. Is it? Oh, no. Sorry. So it goes. Where does it go? Sorry, just I keep messing this up. So bad at drawing these graphs. This is why I like using the quadrant rule, because I'm quite bad at drawing these. goes through 90, doesn't it? Yeah, it does. So it goes through 90, goes back down through 90, as that's crossed 2, goes back up through 270, and it sort of curves, just doesn't go. That's your cos graph. And then your tan graph, we draw. Now, it's quite interesting actually with the tan graph, because when you type in any one of these values with the tan graph, what you get on your calculator is 0. I'm just going to prove this to you now before I actually go ahead and draw the graph. So, if so, you've got you can try this on your calculator, but you've got tan. So it gives you tan. I don't know. Let's type in 90. So you can see that's tan 90. So we close the brackets, press equals. Let's get a math error. So obviously, oh sorry, I'll probably do another one, but so tan of 180, which all these work for the other things we pressed in, that gets you 0. So obviously it's not going to look like them over the graphs, is it? Because otherwise we just have a straight line. So at each point the graph has to be going through 0. So if each one of the graph is going through 0, we can't just draw a straight line, because that wouldn't be a graph. So what it does, oh for God's sake, I'm so bad at these. Actually, you know, I'll rub these graphs off afterwards so I can just use up all the space. So this is the same thing, minus 360 minus 270, sorry, minus 270 minus 180 minus 90, and then on this side we've got plus 90 plus 180 plus 270, and if we add 90 out we get plus 360. So it looks exactly the same as so far, tan of x, except obviously each part has got to be 0. So it sort of looks like this. So you've got one sort of curving at the bottom there. It sort of 270 sort of curves upwards and sort of goes like that. It sort of starts through 90, sort of goes up through plus 90, sort of something like, oh, actually no, it was wrong. Sort of curves, goes through the centre, oh, I've got a really bad cold at the moment. Sort of starts at 90, goes through 180, sort of curves, it should be more of a curve, and then it starts at 360. And it sort of doesn't really go up, but that's how it looks. So, what can we deduce from these three graphs to get that quadrant rule at the top? Well, first thing we can do is, sorry, let me just die for a minute. Yeah, good, I'm dead, so that's good. Now, you may notice what we've got here is values. So 0, and the positives go around in one direction, so it goes 0, 90, 180, 270, 360. That's plus or minus there. And the minus goes that way round, so it goes 0, minus 90, minus 180, minus 270, and minus 360. Now we've put all there because between 0 and 90 degrees, so in the first quadrant, all of these graphs, so the tan graph between 0 and 90, which is a small amount there, 0 and 90 positive, and the tan graph 0 and 90 is also positive. So every single graph between 0 and 90 degrees is positive, it's not negative. However, between 90 and 180 degrees, only the sine x is positive. And that is because if we look, the sine x between 90 and 180, so 90, I can put my finger there and there, it sort of curves up. My finger's totally out of focus there. Except here, between 90 and 180, so it goes down till it's below 0, below the x-axis, so it's negative. Here, for the tan, between 90 and 180, it sort of is below the x-axis, as you can see. So that obviously tells you the graph is going to be
I'll be dead before this is over. Which may please some of you, but never mind. And then between 180 and 270, I've listed that tan x is the only graph. Now this is not tan of x, this is just tan. X is the degree value, by the way. So if we look at tan, it says that between 180 and 270, tan is the only graph that is positive, which is 180, 270, which that curve, I'm not drawing very well there, so it should curve over and go up to the 270 bit, so it's a bit wrong. If you look at the tan graph online, it should look like that. And obviously these two graphs aren't between 180 and 270, they're not, and that's not. And then between 270 and 360, positive, only the tan x is positive. Only the cos x is positive. So the cos x is that one, between 360. There you go. It's negative. That's also negative. So that's how we work out that. That's how we've got to the quadrant rule there. And obviously if you go the other way around, so if you go backwards, so we've got 0 to minus 90. Still we've not moved these things, these individual things around. So what? It's positive. So the sin x is positive, tan x is positive, the cos x is positive in each one, and all of them is that one. It's not very descriptive, but never mind. So between 0 and minus 90, only the cos x is positive. 0 minus 90 is positive. What is it? Oh, cos x, sorry. Yeah, that's negative actually, that's positive. And that's negative as well. So you could sort of, if I just zoom back, you can pause the video, and so that goes 0, minus 90, minus 180, minus 270, minus 360, 0, 90, 180, 270, 360, and there's all degrees of these values of each individual graphs, and if you dot it all up, pause the video, you will come to that quadrant rule at the top there. So that's in essence the whole quadrant rule. Now we go to the second part of the video. I'm just going to rub these graphs off now. I'll leave that top thing, so if you understood this, how we got this, you'll be okay with me rubbing these off. And if you can't, I have spent as long as I possibly can without, slowly dying. I'm sure you probably get at this point. But anyway, we'll continue. Now, I will do a trapezium rule video, which I don't think I've done yet. Sure. If it is up, then I'm sorry, but never mind. By the time I've done this video, it's not. I don't know if it gets uploaded before or whatnot. So, as I was saying, this is the rule. It's really good. What we're going to do is do a couple of questions on here. One of the exam papers says. It says tan theta equals √3. So solve this. So solve tan theta equals √3 for values between minus 360. Theta is greater than minus 360. Theta is less than 0. I thought theta is less than theta, so it's stupid. So, that may look to anyone who hasn't done this sort of topic, that may look quite daunting. And the first thing anyone would do is, well, not anyone, but anyone who hasn't understood this would go straight for the finding out theta and going, well, okay, we'll find out theta, and if it's between minus 360 and 0, it's going to fit this equation. Well, no. I really am going to be dead, because we haven't incorporated this bit into this, and that's the whole point of doing this, so we can work out this graph and sort of put it into perspective, so to say. So how can we do that? Well, if we know the tan graph, we have to ask ourselves, we draw another quadrant like this, and we have to ask ourselves for the graph, because this theta here is not. Well, basically the short story is it's not between minus 360 and 0. So, how are we going to show this on a graph?
Well, we have to think, well, where is tan positive? Well, tan is positive in the bottom left quadrant of this and the top right quadrant, because all of them includes tan. So we draw a line going from the bottom left quadrant to the top right, or the other way around, it doesn't really matter. And the angle that this is specified here is between where the enclosed region, the closed region between the line here we've drawn and the x-axis. So that's theta, and this is also theta. They're the same angles. And obviously you could draw the same angles here. So this is 0 or minus 360, and you could go around that, it'll take it away. And now I'm not going to write every single value on here. I'm not going to write any, because you could just take it off of this diagram up the top. Sorry. So, first thing we need to do is find this angle. And yes, now we found out this, we've drawn it, we can find out the theta. So, if we know tan theta equal to root 3, we inverse tan both sides. It gets rid of tan on the left side, so we've got theta equals tan, the inverse tan of root 3. Now, when we do this, when you put this in your calculator, you will see very clearly why we can't use this. Just do this method without drawing the graph, because otherwise it would give us something wrong. And this gives us theta as being equal to 60 degrees. That equals theta. So both of these angles here equal 60 degrees. Don't forget to include the degrees bit. So 60 degrees equals theta, and 60 degrees also equals also equals theta. So sorry about that, I just had to die for a second. So that's very good, but how does that help us? I mean, what possible way can we sort of eliminate this sort of graph thing? So okay, we've got theta, and the theta we've got is now between 0 and minus 360. But we know it's minus. So as we said on here, pluses go around this way and minus go around the other way, the corresponding way. So minus goes around this way. So the reason I didn't draw the degrees on before was because we're looking at the minus ones in particular. So we've got minus 90 here, minus 180, and minus 270. So what we've got is we've got minus 0, 90, minus 180, minus 270, minus 360. And now it's got to be a minus theta. So we've got to get to this line here. And there's a couple of ways we can do this. The first way we can do this is by going this way. And I'm going to label this. Oh, well actually I'll do it in a different colour. But you see the way I'm going to be going. Just change colour so you don't think it's the same bit. Got any more pens that'll work. So we've got a line here. And we'll label this 1. See if any of my black pen's going to work. We've got a second one going there, so 2. And that is 2 ways. And now this whole angle here, so the whole turn of, the physical whole turn of the second one, I'll zoom in, I don't know if you can quite make it out. So the whole physical turn of the second one there is the angle we want to measure. So you can see it's minus, so if we're going around the whole the anti-clockwise motion for 2 is minus 360, which is the total degrees, take away whatever that is. Now that's 60. Now if we take away 60 we get minus 420, and that's obviously not going to happen, so we have to add on 60. Or, you know, 60 minus 360. So that gives us minus 300. So that's the second. So theta 2, or theta subscript 2, I just like to write it as theta subscript 2, equals minus 300 degrees. And another way of doing this, I will do another question by the way, so if you're not quite getting this, and then theta 1, which I drew in green, is minus 360, that's minus 90, that's minus 180, so it's minus 180 plus 60, and that gets us minus 120. So that's one graph. Now you can see this is a lot simpler than drawing that quite confusing tan graph, I think. So
hopefully I've explained that to you, why we have the sine, tan, cos, or a way of remembering that at the top right is cast, so C-A-S-T, or a better way of remembering it actually is A-S-T-C, but whatever way works for you, as long as you remember top right is all, left is sine, bottom left is tan, right is cos. Now they're all functions of graphs. I've explained that before, but I just thought I needed to nip in and reiterate that, just in case some of you weren't properly listening. Because I know I can be boring as anything, so it doesn't matter. So there we go. That's how to work out the trig functions of graphs. But hang on, if you're still with us and not just clicked off the video because I looked like I was ending it like an idiot, we're going to do a few more questions. So, yeah, probably you want to need to just zoom back if you wanted to copy that down if you hadn't already. What we're going to do is we are going to do a sort of a bit more complicated one, because that one we sort of just drew a straight line. But you may be asking me, well, what if we get a sine and all? So we have to go sine and go through the all bit as well, which is a sine graph. How are you going to draw that? You can't just draw a straight line, because we might get a theta of like 20 degrees, for example, and you can't have a straight line unless it's bent, but we'll do that one. Okay, so how should we do? I just decided which one to do. So it says, I just put 1 again, 2 sine theta equals root 3 for minus 720 less is greater than theta, and theta is less than 720. These are both degrees. Now that looks quite confusing. First of all, because when you see it, it says 720 degrees and max is 360. So obviously it's just going to be twice the way round. Just, logically thinking how many times. They're not going to do where it's like 3/4 of the way round. No, not 3/4. It's not going to be something awkward for you to work out. So that's the start of the graph. First thing we need to do, obviously, is work out this bit, the top, work out what theta is. Well, so the first thing we need to do actually, the first thing we need to, I should have said that, is work out what sort of graph, what sort of line we're going to draw. We need to draw another quadrant, okay? So it's going to look something like this. So we've got the degrees here, and I'm not drawing them because we need to again decide what we're going to use. So we've got all sine, tan and cos. Now if we've got sine here, and sine goes into all, so it's always going to be in this quadrant and this quadrant, and we've got a angle, we will have an angle, so it's going to look something like that. It's going to go in the middle and it's going to go like that. And theta is bound by the x-axis, so that basically means that it touches the x-axis from the line. And now we need to work out this theta. 2 sine theta equals 3. So theta equals, if we simplify this down to get theta, theta equals sine inverse, or the inverse sine of root 3 over 2. And that gets us theta as, we just put them on the calculator. Just stand out of the way a little bit so you can see it. Put in our calculated sine inverse of root 3 over 2, and that gets us 60 degrees. So, I know it's quite confusing, they don't all come out to be 60, but it's just how we've done it. So 60 degrees, and that equals 60 degrees. So it should be looking fairly simple so far. But I'm just going to rub that bit off the bottom and working out, because we're going to need some room for this. So, what we're going to need to do now actually is draw both things going round. So we've got going positive this way, and we're going negative this way. I'm only doing this to help you. So this is plus and minus 360. And so we've got 0. If we're going around this way, we've got minus 90 in brackets, minus 180,
in brackets. I'm only doing in brackets, so you know I'm not taking it away from anything. Minus 270 in brackets. If we're going positive, it's 90, positive 180, positive 270, and positive 360. All I'm doing so far is copying the things from here. Now, what way can we get to these lines? Well, if we go from the positive way, so positive 720, what we can do is we can go, I probably should do this in a different colour, damn it. So, oh god. So, it goes to 1. There, that's one way. Now you could do that a whole way again. So you could add 360 onto that, which we'll do in a minute. Oh, great, I keep picking up green. Why is that? Just green. It's the colour of the day, I think. No offence to that red or anything, but you know. That's the other way, the second way. Now we need to get to the other. We need to go the minus way. So I'm just going to have to do this. I'm going to have to do this in the same colours. So we could go this way to it. We'll call that the third way. Yeah, that's the only other way we could do it. Actually, I'll do that in a different. Should I? That'll be alright. So that's the third way. So we've got 1 here, 2, 3, 4, 5. And 4 and 5 are just like going round again from 1 and 2. So what we need to do now is work out what each of these angles are. I think the easiest one to start with is 1, because it's just the angle there, it's just theta, which is 60 degrees. So theta 1, I probably should draw that in red actually, stop confusing you. Theta 1, all it is 60 degrees. Theta 2 is 180 take 60. Theta 2 is 120 degrees. If we theta 3, it's going to be minus 180 take 60 and minus 180 take 60. Theta 3 is going to be equal to minus 240. Yeah, minus 240. So I was just double checking on the note scheme. Minus 240. Now there are 3. What we need to do, so we can do the third one again. We could go all the way around again for the third one. So we can go. We just do twice of each one. We do twice by each one by adding on the whole term 360. So we add on 360 for each one to get our angles for between this. So theta, we'll call this theta 1. We'll underline it. So you can know. So 360 plus 60 is going to be 400 degrees. 120 plus 360 for theta 2 underlined, or just a little squiggle, or whatever you want to do. Say it is theta 2, but we're going round again because we're crazy. Is going to be 480. And then we've got theta 3 underlined. Instead of adding 360, we take it away because we're going minus again. So we're going a minus way round. So that is going to get us 500. Sorry, definitely not watching another video there at all. And it's minus 5. What was it? Have I done that wrong? Just we'll get figuring out if I've done something wrong. Oh wait, I've missed a whole one out there. Got to go the other way as well to the other one. I knew I'd missed something out. It goes sort of, trying to do it as most out of the way as I can. It goes all the way over to something like that. So that's theta 4. So theta 4 is minus 300 degrees. So that's theta 4 there, I missed that out. 300 degrees. Minus. And if we add 360 theta 3, which is just going up to this side, we get minus 600 degrees.
And if we underline theta 4, so we go round again, we add 360, so that gets us 300, so that gives us minus 660. So we've actually ended up with 8 values for theta there. I've kind of made a bit of a mess of that. So I think that's the hardest one you're ever going to get. Well, it's not the hardest one, but it's, you know, quite hard. I've sort of tried to explain that. I don't want to waste up any more time, so, you know, we'll see you in the next video.